Okay, so this is problem 3 from the 2019 January contest Bronze Division, Guess the Animal. It is also a problem in the complete search module of the Bronze section of the USACO guide, specifically the basic complete search module, and it is the first hard problem. Okay, so the problem states, when bored of playing their usual game, Bessie the cow and her friend Elsie like to play another common game called Guess the Animal. Initially, Bessie thinks of some animal. Most of the time, this animal is a cow, making the game rather boring. But occasionally, Bessie is creative and thinks of something else. Then, Elsie proceeds to ask a series of questions to figure out what animal Bessie has selected. Each question asks whether the animal has some specific characteristics, and Bessie answers each question with yes or no. For example, Elsie could ask, "Does the animal fly?" and Bessie would respond, "No." Elsie could ask, "Does the animal eat grass?" Bessie would respond, "Yes." And then Elsie could ask, "Does the animal make milk?" Bessie could say, "Yes." Elsie, "Does the animal go moo?" Bessie, "Yes." Elsie, "In that case, I think the animal is a cow." Bessie, "Correct." If we call the feasible set the set of all animals with characteristics consistent with Elsie's questions so far, then Elsie keeps asking questions until the feasible set contains only one animal, after which she announces that this animal is her right answer. In each question, Bessie picks a characteristic of some animal in the feasible set to ask about, even if this characteristic might not help her narrow down the feasible set any further. She never asks about the same characteristic twice. Given all of the animals that Bessie and Elsie know, as well as their characteristics, please determine the maximum number of yes answers Elsie could possibly receive before she knows the right animal. Okay, so this problem, and I think that the first important thing to recognize about this problem is that we're in control of a lot of things here. We can choose a lot of things. We can choose which animal Bessie is thinking of, and we can choose the order in which Elsie asks characteristics so that we can maximize the number of yes answers. And this is both good and bad. It's good because now we can forcibly select Bessie to choose the optimum one, and we don't have to just randomly calculate it. But it's bad because, again, there's a very high degree of choices here. So we can choose one of the 4 animals to be, but we will, for example, if right off the bat we get a yes answer for "it is awesome," then immediately we're done because we've eliminated sheep, we've eliminated goat, and we've eliminated bird. And for the time being sake, anything we actually ask in this set right here, anything we ask in this set here is going to eliminate bird. So let's ignore bird for the time being. So if we were to immediately ask, "Is it awesome?" we would eliminate all of these, and that would be bad because we've only asked one yes question. So what do we do? Well, what we do is we take a look. We want to only select the characteristics which are common with whatever the animal Bessie is thinking of and some other animal. For example, Bessie could be thinking of cow, in which case, if we take a look at eats grass, which is this characteristic, the sheep and the cow have it. And then for makes milk, the cow and the goat have it. So that's 2 right there. And then in her final question, which she's guaranteed to almost always get yes in, or always get yes in, we can say, "Is it awesome?" And if so, then we're done. But here's the problem. Let me erase these quickly. Here's the problem. What if we were stuck with something like this? Then what will be the maximum? Well, suppose we're stuck with something like this. If we were to consider, does it eat grass, and Bessie says yes, that would eliminate goat. That'll eliminate goat. And now, take a look right here. She picks a characteristic of some animal in the feasible set to ask about. But what's that characteristic? Well, that characteristic we already tried to do eats grass. We can't do makes milk anymore. We can't do makes milk anymore because nothing in the feasible set, which is just the cow and the sheep, makes milk. So now, let me clarify. We can do makes milk, but once we do makes milk, we'll be done. So what I mean by that is, once we do makes milk, we will eliminate the sheep and our feasible set will be over. So it's just because the cow shares makes milk with the goat, that doesn't mean that we have a free yes answer right here. And I'm saying free yes answer as something which is not like the final yes answer. So we can't use makes milk, we can't use eats grass, or we can use eats grass. So we cannot use makes milk if we use eats grass, and we can't use eats grass if we use makes milk. So the trick here is to recognize that what we're actually looking at is any two animals. So for example, suppose we take goat and cow. Notice that they share two characteristics in common. They share eats grass and makes milk. Well, what this means is I can ask, does it eat grass? Does it make milk? And then a third question, and get yes for all of these. And I'll have maximized the number of yeses I could get just considering these two animals. But let's suppose we added a third animal in. And suppose this third animal shared only one characteristic with cow, as it does here. Well, what you might notice is that since it only shares one characteristic with cow, after two yes answers, we're done. There's no way that sheep can still be in the free set. Or the feasible set, not free set. So the whole point is we want to choose two animals which have the maximum number of characteristics in common. And with those two animals, with the two animals that we have, all we do is we consider, okay, now that we have these two animals, what's the number that they have in common? Add 1 to that, that's our answer. And that extra 1 comes from the final yes answer. Alright, so let's see how to code that. So here in this guess.in file, I've already put the sample input. So now we're going to run we're going to do hashtag include bit/std c++.h using namespace std. We're going to create a main function, and inside this main function, we're going to need to open guess.in and guess.out. So we're going to do free open guess.in read stdin, and we're going to do the same thing for out. So now that we have these, we'll read in, actually first we'll need to define it. We'll read in n. And now that we have n, we'll create a set for each animal. So we'll create a set which is for each animal. So we'll need a vector of sets. A vector of set of ints. And we'll call these characteristics, so I'm going to abbreviate that to C. And this is going to have size n. For int I is equal to 0, I is less than n, I plus plus. First we're going to read in a discardable. And what I mean by that is, we're going to read in string underscore sin underscore. And this string is not needed. It's useless, because we don't really care about the beginning of, or rather the name of the animal. Now, what we need to do, and you might have noticed, I've actually converted this to int. We could definitely do string, but you can also do int if you want. So how, in this case, I'm going to show you how to do int. So how will we do this? What I mean by int is, we convert all of the strings to numbers. So let's take a look. We have a map from a string to an int. This is going to map, this is going to map our string characteristic, so the characteristic in the form of a string, to the characteristic in the form of a map. So what do we do? Well, first, we're going to read in k, and then for int j is equal to 0, j is less than k, j plus plus. We're going to see, okay, first let's read in string ch, sin ch, and we've got our characteristic now. So now let's consider, okay, we've got to run it in a map. So we're going to say if math.contains, or rather count, ch is equal to 0. So if ch is not a key in ma, and I'm sorry, I used m, not ma, then we're gonna say int temp is equal to m dot size, m of ch is equal to temp. And then finally, we're going to say c of I dot insert m of ch. So now we have c of I dot insert m of ch, and now we've initialized all of our characteristics. So now what we need to do is iterate over every pair of animals. And so the way I'm going to do that is I'm going to say for int I is equal to 0, I is less than n, I plus plus, which is our first animal. And then I'm going to say for int j is equal to I plus 1, j is less than n, j plus plus. And what this is doing is this is ensuring that I'm never having j be less than I, which means I'm iterating over every pair exactly once. So now we have our pair, and now we're going to want to compute the intersection. So in C++, in order to compute the set intersection, it's a bit tricky. So what we will need to do is first we'll need to create a vector containing the intersection. So we'll say vector of v int inter, or I'm just going to say inter, and this is going to have have a size of 100, which is the maximum size that the intersection can be. And that's just because there's a maximum of 100 characteristics. And now we're going to say set intersection of our first iterator, which is going to give us, this actually will return us an int, so we're going to say auto it is equal to set intersection of our first set, which is going to be c of I dot begin, c of I dot end, and then c of j dot begin, c of j dot end. Oh, and I didn't mean to do that. Right? And the last thing we actually need is we need our intersection iterator. And this is where it's going to save our intersection. And now we're going to resize our intersection to say inter is equal to resize and then we say it minus inter.begin. So what's going on here? Well, first, right here, I'm plugging in the pointers which are equivalent to the characteristics relating to the ith animal. And so that's c of I dot begin and c of I dot end. And then I have the same thing, but for the jth animal. And lastly, I have the pointer where our intersection is going to be stored. And that's in inter.begin, which is the same as our vector inter. But the important thing to notice is inter is not going to automatically resize. So what we do is we say auto it is equal to the set intersection. And what this does is this returns us the last place where the set intersection happened. And then what we can do is we can say inter.resize it minus inter.begin. And now we have our set intersection. Now remember, with this set intersection, we actually want its size. So we're going to say, given the size, and actually we'll first keep track of our answer, so int answer is equal to 0. We'll say answer is equal to max of answer, and now remember, we want the size of the intersection, so we're going to say inter.size plus 1, because there's our final yes. And that is our maximum. Now you'll notice, maximum right here, it's throwing an error. That's because inter.size is by default not an integer. So we'll need to convert it to an integer. So we'll just do that right there. And now, if you're really being clever, you might notice inter.size is just going to be equal to it minus inter.begin. So we can actually replace that right here. And we'll just change this to be it minus inter.begin plus 1. And we should probably use parentheses. And also maybe and wrapping integer. Right. So there we go. And now the last thing that we can do is we can actually take this out, because we don't need to resize our vector every time. So now we have our intersection. Alright, so we've got our answer. All we need to do, that's all that's left, is to output it. So we're going to output it right there. Okay, and now it's time to test. So we're going to say g++, okay, g++ minus std equals c++ 11 minus wall minus o2 guess.cpp minus o guess. And hopefully you understand what this is doing. This is compiling our code using C++ 11, turning on all warnings, using the O2 optimization flag, and outputting the executable to guess.exe. Alright, so now all we gotta do is test it. And let's take a look at guess.out, and we get 3, which is exactly right. Now let's quickly log in. And I'll refresh the page, choose the file. This is the wrong problem. Let's go to the right problem. That is also not what I meant to click. And we'll run this in C++ 17, submit the solution, and it's grading. And there you have it. Our code has worked successfully, and we're done. So just as a recap, here is the code. We used a map to map the characteristics to integers and created our vector of set of the characteristics, because no animal can have the same characteristic twice. And then we used set intersections to calculate the set intersection, and that should be relatively obvious. It's in the name of the function what it does. And then we computed the answer is equal to the maximum of the answer and the size of the intersection plus 1. And then we outputted it. So there you have it. That's the code. If you guys did enjoy, please don't forget to like and subscribe. It really helps my channel out, and it helps my channel grow. If you have any other problem that you want me to work on, or any other general feedback, just let me know down in the comment section below, and I'll be sure to check it out. And with that, I'll see you guys in another video.